Hi everyone, in this video we will learn how to measure the length of any given function. If the mathematical formula of the function is given to us, we can calculate the length of the any function from in the given interval. Let's draw the y axis, x and y, and let's just try to draw any function here. For example, let's assume that our function is this way and it starts from point A to, for example, to the B on the x-axis. And in order to find the length of this part of the formula, let's call this function fx function. What can we do? In order to find the length of this function, we should just divide this function into small pieces and apply the Pythagorean theorem to each part of them. Let's just remember the Pythagorean theorem. A, B, C. A squared plus B squared is equal to C squared. As I mentioned in one of the previous videos, when I proved the Pythagorean theorem, it's one of the most important theorems of the Euclidean geometry, and also it can be used in different parts of the mathematics. And in order to find, let's just draw small triangles and try to apply this function, just drawing very small, very tiny, infinitesimally tiny right angle triangles, and this will continue. And when we come here, let's just continue to draw the triangles, and let's draw it till certain point, and let's draw it a little bit bigger here to just analyze how we find it. What is this part of triangle? It is delta x. How much our x value changed from this part to this part, and think that it is infinitely small part of this function. And here the projection can be seen on the y-axis, and therefore it is delta y, which is the infinitely small change in y-axis. And in order to find this part, we should just sum the squares of this delta x plus delta y, and this will give us the very small part of the length and its square because of the Pythagorean theorem. And in order to find delta L, we should square root delta x squared plus delta y squared. We should find the sum of this term, delta x squared plus delta y squared, at starting from point A to point B. What can we use here? Another tool, very important tool that is used in mathematics, is integration. We can integrate from point A to point B and sum infinitely small parts of this function and get the final result in terms of the length of our function. Let's just write it. We can write that integration starting from A to B. Let's write the formula that we found. Square root d, let's write it in the form of dx squared plus dy squared. And how can we get the final result? In order to find the result, we should just write it again, and let's just get the x value out of the square root. Let's write it here, which will look more like an integration as what we see at schools, at universities in a traditional way. Square root, if we took this term out of the square root, if it was the x squared inside of the square root, therefore we will get here 1 plus dy divided by dx squared. What is dy divided by dx? Divided by dx is the differentiation of the function with respect to x, and therefore we can write the final formula in terms of just using this dash notation of the derivative 1 plus f dash x square derivative x at point x square dx, and we can write here any function we want and find the length of that function within the given interval. At our case it was from a to b. And this is the end of our video. I know that this video was a little bit short compared to the previous ones, but I think it was beneficial for you. Thanks for watching. Please like, comment and subscribe to my channel.